Hey guys, happy Tuesday. I'm posting this on a late Tuesday night. I just want to give you some time to finish up some of the assignments that I've left posted. I hope you guys are doing well, and it's nice that things are hopefully moving to better grounds in the next couple of weeks. So just be patient, hang tight, and continue to check up on each other, whether it's on iMessage or just sending messages amongst you through different social apps. Just, keep that going, and don't worry, things will get back to being normal soon. So I wanted to start a probability unit. So basically we have 2 units of probability, and then that's it for the semester. I can't believe, that we're almost towards the end of the year. However, I'm going to try to go through the next 2 sections or chapters as best as possible so that you can understand and follow along with the lesson notes and the video. Okay, so today we're going to talk about probability with tree diagrams. And actually, if you guys can remember the very first day that you guys stepped into my classroom, I did have a task that I guess put up around the room. So you guys went into groups of like 3 or 4, and I said, this is a grade 8 problem, and you guys did your solutions. There were a couple of coins, and I think there were 5-digit numbers, and you had to come up with, a number of your own or see how many possibilities there were. So when I showed you the solution, I actually showed you the solution with tree diagrams. So that's how we're going to start this unit, and we're going to talk about probability and just basically uncover how it can help us solve word problems by drawing out a tree diagram to help best figure out how many options or possibilities we have. Now, in grade 8, you're first introduced how to do tree diagrams. It might even be a little earlier than that as well. I remember looking at different combos. So if you had a choice of drink, a choice of side, and a choice of sandwich, how many different possibilities can you have? Definitely using a tree diagram would help figure that out. Okay, so just a few couple points to start off with. So a few thoughts on probability. Probabilities take values between 0 and 1. Okay, so we can think of that as 0% to 100%. Okay, exactly 0 and 1 are boring probabilities. So for instance, if I was to think of something that I know will never happen, I know there is a 0% chance that I will ever become a firefighter. Right? I have terrible fear of heights. That job isn't for me, right? Or I am 100% sure I will drink water each and every day. Okay? Now, again, probabilities usually lay between 0 to 100%. If it is 0 to 1, just think, 0.10 represents 10% or 0.97 represents 97%. Probabilities can be hard, right? So you have to have an understanding of, I guess, the question and what exactly is at hand in going through the example. And the reason why it's difficult is because you use so many operations. Okay, so sometimes you multiply, sometimes you add, sometimes you divide, and this is why probability can be tricky sometimes. There's so many different rules, we don't necessarily know what to apply when. I know sometimes in math we get this rote ability where we know, say when we do BEDMAS, we always go in a certain order. In this case, we have to really figure out what question is really trying to get at by the time we get to our solution set and so forth. Now, tree diagrams are very useful for calculating probabilities, and they definitely display the different types of outcomes or combinations and their probabilities. Okay, so a few rules and things to keep in mind. Outcomes are listed at the tip, so that means at the very end of each of the branches. Probabilities are written beside the branches, so you'll see that I'll be writing either in decimal form what the possibility is of that probability, and each level of the tree or column of outcomes is clearly labeled. So you'll see that we will do that together and just work on how to properly label a tree diagram. Okay, so we'll start with our first example. Okay, so I'll just move this down. Again, feel free to, if you have a printer, print the lesson, write them in as you watch the video. If you don't have a printer, even if you want to just take out a side sheet of paper and work through some of these examples by jotting down some notes, making your own notes, or if you want to just review the finished copy and kind of follow through the video, that's okay too. Okay, so cater to what you believe is your best learning style. And we'll start with the examples here. So for number 1, Martin lives in Kingston and is planning a trip to Vienna, Austria. He checks a website offering inexpensive airfares and finds that if he travels through London, England, the fare is much lower. There are 3 flights available from Toronto to London and 2 flights from London to Vienna. If Martin can take a bus, plane, or train from Kingston to Toronto, how many ways can he travel from Kingston to Vienna? Okay, so lots of information, lots of things to think about. So what I'd like to first start with is our first phase. Okay, so he lives in Kingston, and if you've ever been to Kingston, there's obviously not that same international airport that Toronto has. Okay, so we need to figure out, I apologize for not being as clear. Let me see if I could try that one more time. Toronto. Okay, so we want to see Kingston to Toronto. Okay, so for Kingston to Toronto, okay, we have this idea that once he gets to Toronto, he actually has options, right? So in terms of getting there, the options that we have been given, he can take a bus, he could take a plane, and he can take a train to get to Toronto. Okay. Now, the options out of Toronto, as I mentioned, there are lots of different options there. It states that there are 3 flights available from Toronto to London. I'll just go TO to London. Okay, so let's say Buddy or Martin, we'll use his name, he takes the bus from Kingston to Toronto. He then has 3 possible flights he can use, right? 3 possible flights to get to London. Okay, in terms of how he got from Kingston to Toronto, if he took a smaller plane, he still has 3 different options to get from Toronto to London. And the same thing if he took a train from London or Kingston to Toronto. Okay? Now, once he finally gets to London, he finds out that there are 2 flights from London to Vienna. So now we're going to think about London's travel to Vienna. Okay? And in going to Vienna, which is our final destination, we know there are 2 flights. So we can say A, we can say B, AB, 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 AB. Okay, so even if I just go back, oh, that's not nice. AB, AB, and you get the idea. Now, because this question doesn't actually give us any probabilities, this is just used to help set up how to create a proper Venn diagram, tree diagram. I just wanted to show you how many ways that we can find out that he can travel. Okay, so in terms of finding the ways that he can travel, we got to look at our tips. So if we count all of the ends of our green extensions, okay, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we can conclude there are 18 ways. So Martin can travel 18 different route from Kingston to Vienna. Okay, so Venn diagram does help show all of those options. And when you look at it, you can say, well, if he took, say, the bus, the first route from Kingston to Toronto, you can follow this branch to bus, and then let's say he took the second flight option, and then took the flight A option. And as you follow through that branch, that shows one possibility of a route that he could have taken. Okay? So hopefully that makes sense and that recalls a little bit of work that you might have done back in the day. Okay. Now I want you to think also of the different routes that we had. Okay. So if you look here, bus, plane, and train, in our first travel leg extension, there are 3 different ways. Okay. Out of the flights from Toronto to London, there were 3 different flights. And then out of the options from London to Vienna, there are 2 different flights. So actually, another way we can see a connection to, in terms of figuring these out, if we multiply our options, 3 times 3 times 2, we actually get 18. And 18 does represent the amount of travel ways that Martin can get to his final destination. Okay? So you can kind of see how probability and the works of tree diagrams does actually help in terms of trying to figure out our different probabilities and possibilities as we work through them. All right, so we'll try number 2. Okay, so for number 2, we have use a tree diagram to display the possible outcomes when a coin is tossed 3 times, and use it to find the probability of tossing exactly 2 tails. Okay, so we know on any coin there's only 2 options. So there's a 50-50 chance. So it's either going to be heads or it's going to be tails on a standard coin. Okay, so if we take our coin, I'll just draw a $sign here. We want to figure out when a coin is tossed 3 times, what is the probability of tossing exactly 2? So we're actually looking for exactly 2 tails. That's the outcome that we want to find. Okay, so because there are 2 options, it's either going to be heads or tails. There's a 50-50 chance of either outcome happening. Okay, so this is our first round. So I'm going to put 0.5, 0.5 along the branch to represent our possibility. Okay, and then I put tails with the 0.5 as well. Okay, so this represents our first round. Okay, I got to do this 2 more times because I want to toss this coin 3 times. So from my heads route, if I take this coin and I flip it again, I still get a 50% chance that it will go heads, 50% chance it will go tails, and the same for the other route. So 50-50. Okay? Now, this represents our second toss. For a third toss, it has the same probability. I'm just going to write out our options first. Okay, so we're trying to find out the probability of tossing exactly 2 tails. So if we were just to take our first route, so I got heads, heads, heads. Okay, heads, heads, heads is not what I want. I'm looking for 2 tails. Okay, so we're going to scratch that route. Okay, now if we take the second route, we have heads, heads, tails. Okay, still not what we want. For our third route, we have heads, tails, heads. Okay, not what we want. For a fourth root, we have heads, tails, tails. Aha! I'll use a different color. We have a winner. Okay, that's one possibility. Okay, we got to continue to see if there's any more. So for a fifth root, tails, heads, heads. Okay, nope, not what we want. Sixth root, tails, heads, tails. Okay, possible. We will highlight that in green. Okay, and we got two more options here. We have tails, tails, heads. Yes, that is what we want. And tails, tails, tails. Now, because tails, tails, tails is actually three tails, that actually goes against what we're trying to find. We're trying to find exactly two tails, so I'm not going to count that one. Okay. Now, in terms of finding the probability, to find the probability, we got to figure out what the probability of each branch is. Okay. So to find the probability of each branch, we got to multiply along the branches. Okay. So what that means is we're going to multiply 0.5 times 0.5 times 0.5. Okay, I'm just going to put 0.5 in brackets. And because each opportunity is pretty much 0.5 times 0.5 times 0.5, amongst all of those probabilities that I've highlighted in green, they will all equal 0.125. Okay, so there's a 12.5 chance that this outcome can happen, a 12.5 chance that this outcome can happen, and a 12.5 chance that that outcome can happen. But to find the total probability of the sum of this outcome, I'm actually going to add them up. Okay, so I'm going to do 0.125, add it up 3 times, and I get 0.375. So this means that the probability of exactly 2 tails is equal to 0.375 or 37.5%, right? If you choose to express that as a percentage. How are you doing so far? That's okay so far? All right, cool. Okay, so no, I don't want to do that. I'm going to move on to our third one. Okay, so a school soccer team has a history of winning 50% of its games played on a rainy day, 60% of its games when it doesn't rain. The weather forecast for the next game calls for an 80% chance of rain. Display the possible outcomes using a tree diagram and find the probability the team will win the game. Okay, so there's a couple of different probabilities here, whereas in the previous example too, it was all 50-50 chances. Okay, so let's consider our first possibility. Okay, so what we got here is we want to see what happens in terms of our first game. So the weather forecast for the next game calls for 80% chance of rain. Okay, or for the next game. So we got to consider what will happen in the next game. So out of our weather, it's either going to be 0.80 chance that it will rain, and to figure out what happens when there's not rain, well, that's 0.2. It's 0.2 because we know 1 minus 0.8, the remaining probability is 20%. Okay. Now, the first sentence, a school soccer team has a history of winning 50% of its games played on rainy days. So let's say it rains. So that means we can either win or we can not win. Okay, so if we win, there's a 50% chance that we will win, and there's a 50% chance that we will not win. Now, if it doesn't rain, there's a 60% chance. Okay, so that means there's a 0.6% chance that we will win if it does not rain. And if we lose, Well, there's a 40% chance that might happen. Okay, so we want to find the probability that the team will win a game. So let's figure out which branch works in our favor. Well, if it rains and we win, these are the probabilities that help figure out what that outcome is actually. Okay, and if we win when it doesn't rain, these are the two probabilities that will help us figure out what chance do we actually have as a team. Okay, so like we did earlier, we're going to multiply along the branches. So we're going to do 0.8 multiply by 0.5 and get 0.40. We'll keep that answer. Okay, then we're going to do 0.2 multiply by 0.6 and we get 0.12. And we're going to keep that answer. Now like we did earlier, actually I used purple last time, we'll just be consistent. Therefore, the probability of a win for the girls soccer team is a 40% chance or probability. If it rains, they may win. If it doesn't rain, there's a 12% chance. Okay, so these are the numbers that I got from multiplying along the branches, and that means that there's a 52% chance that this team will win the game. Alrighty. Okay. So I have one more video, or one more question to do on video, and this one deals with something that probability really loves to work around with, is what are the odds of these three scenarios coming together. Okay, so it reads, consider an experiment in which you flip a coin first. Okay, so that's the first thing that happens. Then you roll a 6-sided die. Okay, and then pull a card from a deck. So hopefully you know a little bit about the different suits and cards. Okay, there are hearts, there are spades, there are diamonds, and there are clubs. We want to find what is the probability of tossing tails, rolling an even number, and pulling a heart. Okay, now we're given a particular order that we have to follow, so we'll start with the order that it begins with. Okay, so if we have a coin, it's either going to be tails or not tails. Okay, I'm starting to do this probability where we do the option that we want and not the option. Okay, and this will all kind of come together for when we get to our more trickier units. Okay, so there's a 50% chance that we get tails, 50% chance not tails. Okay, the second thing then is then rolls a 6-sided die. So we know a 6-sided die, 1, 2, 3, 4, 5, 6, can either have even numbers or have odd numbers. And because there's a 3 and 6 chance of each happening, that's 50% and 50% in either direction. So even or not even. Even, not even. Okay. Now what is the probability now of pulling a card from a deck that is pulling a heart, and we're not counting the jokers? So remember I said there's a 1 in 4 chance. So if we get a heart, we want to see what happens when it's not a heart. Okay, so heart, because it's 1 in 4, that's a 25% chance, and there's 75% chance that it will not be a heart. Okay, heart, not heart, heart, not heart, heart, not heart. Okay, 25% chance it will be a heart, 75% chance it's not. 25% chance it is a heart, 75% chance it's not. Okay, so we are looking for the outcome of tossing tails, so it has to be this, an even number, so our first branch, and pulling a heart. Okay, So like we did earlier, we want to find the probability of tails, it's even, and it's a heart. Okay, so we're going to multiply along the branches. So 0.5 times 0.5 times 0.25. Okay, that's 0.0625. So there's about a 6% chance that this combo will happen. Okay, so hopefully you enjoyed this lesson. There are a couple of support questions that you can complete. So there's 5 questions here and your answer keys that come with it. Okay, so we are starting our chapter 4. That was just 4.1.